No.
Yeah. So guys, do you understand this line? Do you understand up to this line?
Yes.
Okay. So this line is simple. Okay. How this line is a new line. Okay. Maybe it didn't came from came from this line. So this line is a new line. Okay. So how do I get this? We know that dy is equal to y derivative dx. So e to the power x dx, it will be d e to the power x. Because if you calculate the value like derivative of this function multiply dx, so e to the power x derivative, it will be also e to the power x and then dx. Okay, from this formula we can write down like e to the power x dx is equal to d e to the power x. Am I right? So now you just take this part. You take this part, okay? And you just multiply a minus here. So that means this minus will if you take this minus, you can take this minus to here and here. Okay, you can take this minus to in the power and also in also with the also here. Okay, so now you see here what we have. We have e to the power minus 6 d minus 6. So we can write down this way, d e to the power minus 6. Okay, d e to the power minus 6. And if you want to calculate the value d minus 6, also use this formula. Okay, also use this formula. So d minus 6, it will be minus x derivative dx. So derivative of minus x is minus x derivative dx is minus dx. Guys, do you remember? Minus x derivative, this is only minus 1 from the formula. You see the first formula, ddx of x is equal to 1. Okay, so ddx of minus x, it will be minus 1. Okay guys, so derivative of minus x will be minus 1. So that's why we get the final result is minus dx. So e to the power minus 6 dx. Where we started? Yeah, we started here, e to the power minus 6 dx. So you see minus dx d minus 6. Okay, e to the power minus 6 dx, it is d to the power minus 6 and it will be minus dx d minus x. Okay, so d minus x, this part, so we get d minus, and this is also a new line. Okay guys, do not miss these things because I just took the note what Lausi wrote in the whiteboard. So this is a new line and also this is a new line. Okay, here all these three lines, they are new line. Okay, new line, new line, new line. Okay guys, so Lausi just divided different part here, like d minus x. this part is here. Now she calculated d minus x here. So d minus x, we know that it will be minus x derivative dx, okay? And derivative of minus x, that is minus 1. So ultimately then this is minus dx. So now we can just substitute minus dx here. Okay? So we get e to the power minus x, then minus dx. Okay? And now take this minus on the left. So you get minus e to the power minus x dx, minus e to the power minus x dx. So this is I wrote here minus integration e to the power minus x dx. We also know that we can take this minus out of integration sign, right? So Topu, Lucy, Julian, do you understand? Hello?
Yeah.
Okay. I think it's a little complex, but later on you can just, you don't need to follow all these things. As you already know that we can somehow calculate this part, and we can get minus integration of e to the power minus x dx. Okay, so you can think another way, like you don't need to mix all these things. Just forget this. Okay, and what you can do, so you see here we have e to the power minus x dx, right? It is we have to convert it like dv. Julian, do you remember? Lucy, do you remember?
Yeah.
Okay.
Yes.
So we started here. So already you know x is equal to u, and we have to somehow convert e to the power minus x dx as dv. That means we have to remove this dx, and we have to write down dv. So you can just take this minus down. You can just take this minus down, okay? And take this e to the power x here, okay? Replace this x and write down e to the power x. So sorry, e to the power minus x. So take the minus out and write down all these things like e to the power minus x instead of x. Okay. So so minus integration of x d e to the power minus x. You don't need to calculate or explain here. Okay, this is just the notes. Now integration of x d my e to the power minus x. This is a formula. This is the integration by part formula, right? So it will be u multiply v minus integration of v multiply du. Okay. Now you calculate integration of e to the power minus x dx. So again, we don't know how to calculate e to the power minus x dx, right? That means we again get some, we again have to use integration by part rule, or integration of e to the power minus x dx. Okay. Do we need to apply part rule? Maybe no, not the part rule, but we can calculate it in another way. E to the power minus x and minus. Okay, let me use a Symbolab here, and let me see what procedure they used. Symbolab. E to the power minus integration of e to the power minus x dx. Oh yeah, they used here substitution rule. Okay, use substitution rule. So minus x is equal u. So we know that from the formula we can take the constant out. That means constant is minus here, okay, or minus 1. So we take minus 1 out, and next we have integration of e to the power u du. So integration of e to the power u du, that will be e to the power u. So here is e to the power u, and we just substitute the value. That means we already let u is equal to minus x, right? U is equal to minus x. So we substitute back u is equal to minus x. So then we get minus e to the power minus x. So guys, this part here we used u substitution rule. That means on number this line, okay, this line, e to the power minus x dx, we used u substitution rule here. We already talked about substitution rule before. So that is we have minus x, so we let minus x is equal to u, okay. So where is that? Yeah. So if we let minus x is equal to u, then we get integration of minus e to the power u du, okay, as u is equal to minus x. So how do we get this minus sign? U is equal to minus x. Integration of e to the power minus x dx. If this is u, how do we get this minus sign? Oh yeah, we need to go back to our previous lecture. What is substitution rule? Yeah, so do you remember, guys, substitution rule? If we let u is equal to 2x, then we have to differentiate on the both sides, and then we have to find the value of this part. That means, for example, let me give you a simple example. Simple example, okay. See here we have 1 by cos square 2x. We have 1 by cos square 2x dx. So here I am discussing about the substitution rule, u substitution rule, okay. 1 by cos square 2x dx. So we know that how to calculate cos x, but we don't know how to calculate. We know that how to calculate cos x, yeah, but we don't know how to calculate cos 2x. We have to let this part 2x. This is equal to u. So u is equal to 2x. Okay. Okay, guys, see here. I'm showing you. We know how to calculate integration of cos x dx, right? But if we write down 2 here, so we don't know how to calculate integration of cos 2x. So that's why we have to let 2x is equal to u. we have to let 2x is equal to u, and then we differentiate on the both side. See here, I multiply d on the both side. Here is a d and here is another d, and d2x, it will be 2x derivative dx, right? From the formula. And now if we only keep dx on the on side and take everything else on another side, so 2x derivative, it will be only 2, and if we take 2 on the left side, so it will be divided. So that means dx will be half du. Take this 2 here, and two dx, yeah, and oh yeah, sorry, not this line. Take this 2 here, take this 2 here. Okay, guys, do you can you see this comma here? So this is the second line. Okay, this is the second line. That means I calculated du or d2x all this way. Okay, so I get du is equal to 2 dx. Okay, guys, now I take this 2 on left side. Okay, so I get on by 2 du. Okay, on by 2 du. That means dx is equal to half du. Guys, can you understand? You have to talk. Otherwise I cannot understand. Hello, Topu,
Yeah,
Julian.
I can understand.
Okay. You can just switch on your mic. Okay, you don't need to mute your mic. So yeah, my target is to have a conversation with you and to share our ideas, like what you think and what I'm teaching. Okay, so it is not like our regular class. So see here, we get dx is equal to half du, and then we just substitute it back to our main function. Okay, here. So here dx, we substitute here. Okay, dx is equal half du. So you see, 1 by cos square, that is sec square. 1 by cos square 2x. So we already let 2x is equal to u. That means 1 by cos square u. This will be sec square u. Guys, do you remember 1 by cos x, 1 by cos theta? We learned it in our high school. 1 by cos theta is equal sec theta. Guys, remember this? That means 1 by cos square theta will be also sec square theta. So I write down here 1 by cos square 2x, it will be sec square u, because 2x is equal to u. Okay. And now for dx, we found that dx will be half du. So I just write down here half du. So then I take the constant out. So I came here because we have here e to the power minus x dx. So we can use substitution rule here. That is, for minus x, we can let minus x is equal to u. So, and then we have to differentiate this. We have to differentiate on the both side, like minus x is equal to, we let minus x is equal to u. And then we have to differentiate on the both side. So we know that du, it will be e to the power minus x dx. Okay, where I was doing it, I was doing it here. E to the power minus x dx. So we have to differentiate on the both side. Oh no, where is the pen? Okay, so you see here u is equal to minus x. Now we have to differentiate on the both sides. So du is equal to d minus x. So d minus x, it is minus x derivative dx, right? And minus x derivative, this will be minus 1. So minus 1 dx is minus dx. So du is equal to minus dx, okay? So du is equal to minus dx. And if you just take this minus on another side, so we get finally du is equal to minus dx. And if you take this minus on the left side, so you get minus du is equal to dx, right? Minus du is equal to dx. So guys, see here, we had a dx. So we write down what? We write down minus du. Am I right? Lucy, can you understand?
Yes.
And how about Julian and Topu?
Yeah.
So I took very long.
Julian was the one who answered first.
Sorry?
Said yes. Julian was the one who answered first. Said yes.
Okay. So Julian and Topu and also Lucy, you guys all can understand, right?
Yes.
Mm-hmm.
I took a very long way because I was also confused. You see here, to solve this, we need to learn substitution rule and also the integration by part rule, right? So if you guys like, then I can again explain this in a very short time. Okay, let me let me explain it again in a short time. Okay. So why we are using substitution rule here? Do you know the reason?
No.
Because we don't have any formula how to calculate e to the power minus x. Okay. We have the formula like how to calculate e to the power x. Okay. But we don't have the formula how to calculate e to the power minus x. That's why we have to use substitution rule. So here you will be minus x, okay? You will be only minus x. And then we differentiate on the both side. That means here we differentiate on the both side. Okay? U is equal to minus x and we differentiate on the both side. So d minus x. So d minus x, it looks like dv, right? Or dy. It looks like dy. So we can call it like y derivative dx. Guys, do you remember this formula? dy is equal to y derivative dx. Okay. So y derivative, here y is minus x. So derivative of minus x will be only minus 1. And then dx. Okay. So this part, it makes minus 1 dx, right? Now, okay. So now we can just write down here like minus dx. Okay. So we need to take this minus on the other side. Let me erase this. Okay. So we got here. This will be du, and the right part, this will be minus 1 dx. Am I right? So now if I take this minus on another side, so I will get minus du is equal to dx. Okay. So for dx here, I can write down minus du. Okay, guys. Now take this minus out, and you get integration of e to the power u. So e to the power u, that is also e to the power u, right? From the formula. And then you substitute the value of u here. Substitute back the u, okay? So it will be minus e to the power minus 6. And lastly plus c, okay? So guys, can you understand this? Hello?
No.
Repeat.
Should I
Yeah,
repeat?
mom.
Should I repeat?
No.
Hello?
No. No.
Okay, I see. So let's go back to our main math. So we know that the integration of e to the power minus 6 dx, the result is minus integration of e to the power minus 6 and d to the power minus 6. So we know that the result is minus e to the power minus 6 plus c, okay? From here, minus e to the power minus 6 plus c, okay? And now let's talk about how to calculate this. Let's implement some tricks how to find more quickly. So we have integration of e to the power minus 6 dx. So we can just multiply a minus here, and also we can just multiply a minus here, okay? So this part and this part and this part, to make them similar, we change here, okay? We change here, and this part is also here, and we change here, okay? That means we have to make these three things similar. That means firstly these two things, here and here. So if we want to make change here, like if we want to make change here, okay, here, okay, if we want to make change here, we also have to multiply a minus here. So that is the trick, okay? If we want to make change inside of d, then we have to multiply a minus here, or outside of the function, okay, outside of the integral. Or you can also multiply it here, okay, before e to the power minus 6. They are same. So again, you can just take this minus 1 out of the integral sign, right? So this is the trick. So integration of e to the power minus 6 d to the power minus 6. You see the two variables are similar. The two variables are same, right? So that's why we can write down this way. And we already know that integration of e to the power x dx, it will be what? It will be e to the power, this is the formula, okay? E to the power x plus c. Guys, remember this formula? Number 6, okay? Formula number 6. So it is we can use this same formula here because our variable are same. Here is minus 6 and here is also minus 6. So we can write down e to the power x plus e to the power minus 6 plus c. And this minus, this is here. Okay, guys? So do you have any question here?
No.
No?
No.
This is Julian or Lucy?
Julian.
Okay, how about Lucy?
I'm clear.
Clear? Okay. And how about Topo?
Yeah, okay. Got it.
Okay. So we have to practice more, okay? Also, I need to practice more because I only saw this only on time, okay? After the class, I reviewed it only on time. That's why I'm having some problem to teach you guys. But yeah, I can definitely find a solution and help you guys to understand. How about number 6? We have integration of ln squared x dx. So do you remember my formula? I love pet. Oh no. So this is not my formula, okay? I'm just joking. So here is integration of ln squared x dx. So ln, that means our log function, right? So here log L, and we have also x here. So x is a power function, right? So we have to let u is equal to ln x, and this x here we have to let it as x. So you see we have b already set. Guys, see here we have dv. Okay, that means it is more easier. Am I right? Okay, so we can just implement the formula here directly. So integration of u dv. So u multiply v minus integration of v into du. Okay. So look at here. We have d ln square x. So how to calculate this? Do you remember? Ln x derivative dx, right? Ln square x derivative dx. So ln square x derivative, here is the critical part, okay? So now you see here, we know how to calculate ln x, but we don't know how to calculate ln square x. That's why we have to use chain rule, okay? Because here we are doing differentiation. You see, it is not integration, guys. This part is dy. So dy is equal to y derivative dx, right? So here we are calculating the derivative. That means we are differentiating. So y is ln square x. So you see here we have ln square x derivative. That means we have to use chain rule, because we don't know how to calculate ln square x. So chain rule is outside inside function. Guys, remember, outside inside function. So outside function is ln square x. That means a square. So when we get something like x square, how to make derivative? You know, we just take this power down here, and we decrease the power by 1, right? Like 2x to the power 2 minus 1. 2x to the power 2 minus 1. That means 2x to the power 1. Okay? That means only 2x. So x square derivative, that is 2x. So here also ln square x derivative, it will be firstly 2 ln x, right? And then go to the inside function. Inside function is ln x, right? Guys, inside function is, we have already calculated x square. So inside function is ln x. So ln x derivative is 1 by x. Okay? Guys, do you understand? We had ln square x, so we can also write down this way, ln x whole square. So this whole square is square. This is our outer function. So we can write down this way, 2 ln x. And then into our inside function is ln x. So derivative of ln x will be 1 by x. Okay? So ultimately we get 2 ln x into 1 by x. I have to write down here 2 ln x into 1 by x dx. Okay? Topu, can you understand?
No, bro. Basically,
Oh, how about Lucy? Do you understand?
Not really.
Oh, not really. From where? From this chain rule?
No, you lost me here. And
Okay, from chain rule, right?
yeah.
Okay. So see, we are doing some very cool integration, but suddenly some complex function came out, and we don't know how to calculate ln square x. So that's why we use chain rule, and chain rule is outside inside function. So here we have ln square x. Oh, sorry. We have ln square x derivative, right? So derivative of ln square x, it will be firstly outside function. Outside function is this square. So if we take this square down here, So outside function is x square. So let me just write down here. So it was ln x square, right? Ln x whole square. So you have to take this power down. You have to take this power down here, and we have to decrease the power. We have to decrease the power by 1, okay? So 2 minus 1 are here, it will be 2. So 2 ln x to the power 2 minus 1. Okay, let me clear this. So we have ln square x and then derivative, right? So we have to use chain rule here. So firstly, this is our outer function, this 2, okay? We can take it down here. So it will be ln 2. It will be 2 ln x, okay? 2 ln x, and x to the power. We know that we have to decrease the power by 1. 2 ln x to the power 2 minus 1. So 2 minus 1 will be 1, right? And we don't need to write x to the power 1 because x to the power 1 is x. Okay, guys? Clear up to here?
Yes.
Yeah.
Okay. Now chain rule tell us that this is the outer function. Now we have to calculate the inside function. So inside function is ln x, right? So derivative of ln x is 1 by x from the formula. You see here, this is the integration sign, okay? Derivative of ln x. Derivative of 1 by x equal ln x, ln x. You see here ddx of log x equal 1 by x. So log and ln, they are same, okay? Because they both are logarithmic function. Guys, can you see here? Derivative of log x equal 1 by x. So here again, derivative of ln x, it will be 1 by x. So ultimately we get 2 ln x into 1 by x. So I write down here 2 ln x into 1 by x. Lucy, can you understand?
Yeah.
How about Topu?
Yeah, I understand. But
Okay. But Julian?
No, I understand.
Okay, so let's move forward, okay? Now we can cancel this x from both sides. So we can take this constant out, right? So we get 2 integration of ln x dx. And now, now we have to apply integration by parts formula. Okay, again, guys, we started from integration by parts formula, and we also use chain rule. And again, we get something like we have to apply integration by parts formula again. Okay, because why? Because here we have integration of ln x dx. Okay, integration of ln x dx. So we don't know how to calculate ln x dx. Do you have any formula for ln x dx? No, we have formula of integration of 1 by x dx, but we don't know how to calculate integration of ln x dx, right? So again, we have to use integration by part formula here, okay? So it is maybe simple, like we have to let ln x equal u and x equal v, okay? That means integration of u dv. So it will be u multiply v minus v. You can see here I write down d1 because already